Hey everybody, Mr. Judson here. So we've got one day left of graphing, and the only one we haven't talked about yet is what's called the rational function. And when we say rational numbers are numbers that can be written as fractions. So the rational function is a fraction. And don't worry, sometimes we say, oh, I don't like fractions. This isn't scary. It's just like everything else. I just need to know what it looks like and what are the rules. Okay? Some of the rules we already know because they're the same from function to function. They don't change. So what we need to do is we need to look at this and first of all think to ourselves, what does the parent function look like? The most basic one. And that would be y equals 1 over x. All right? So if I make myself an xy table and I fill this in. Now, first of all, we need to realize that x cannot equal 0. If it does, then it's undefined. And you guys have talked about this before. What it means is we have an asymptote at x equals 0 because if you can't plug the number in, it can't ever equal anything. That's what an asymptote is. It's a dotted line that your graph could never hit. So if I was going to graph that over here, I would do this. And there's an asymptote right there. Can't hit that line. Okay. So now let's plug in a few numbers here and just see what happens. So if I plug in a 1, 1 over 1 is 1. If I plug in a 2, 1 divided by 2 is 0.5. If I plug in a 4, let's say, then 1 divided by 4 is 0.25. And one of the things that we kind of realize here is the larger this number gets that I plug in the denominator, the smaller the value of the fraction. If I plug in a 10, 1 divided by 10 is 0.1, so we're getting smaller. Plug in a 100, it's 0.01. And so what that means is I hit this point right here, but then I got smaller, and then I got smaller, and I'm going to keep on getting smaller. But my question is this: can I ever make this fraction equal 0? No. I mean, some people might think, yeah, just plug in a 0, but we can't do that because you can't have 0 in the denominator. Doesn't work. I think as these numbers get larger, the value of this fraction gets smaller and smaller and smaller, but it'll never equal 0. So I think what that means is it gets closer and closer and closer to this line, but never quite touches it. So again, that sounds kind of like an asymptote. We're going to have a horizontal asymptote right here that we get really close to. Now, what if x equals 1/2? If I put the fraction 1/2 here, since we're dividing, you got to flip it over and multiply, and what I get is 2. So at 1/2, we're up here at 2. What if I do 1/4? Flip it over, you get 4. So now we're up here somewhere. So what we get is this curve that looks like this. And then I ask myself, well, what if all these numbers were negative? Well, a positive 1 divided by a negative would make all of these negative. And so in which quadrant are both x and y negative? That would be down here. And so that same curve is going to happen here as well. And so that's our parent function. That's what these type of graphs look like. I get these two curves. There's two sets of asymptotes there. And so I just got to get it in the right spot. Just like everything else we've graphed. We just got to get it in the right spot. So what are some of the rules we've talked about so far? Well, what happens if a is negative? What does that do to this graph? Yeah, we know this by now, right? It flips it across the x-axis. So this piece would flip down here, this would flip up. So if A is less than 0, which means it's negative. Then I would have my two asymptotes. And this part would flip down, this would flip up. The graph would look like this. Okay? What would happen if B is negative? Same as everything else. We're going to flip this graph across the y-axis. And it really looks the same as this. Okay? So if B is less than 0, here's my asymptotes again. This piece, instead of flipping down here, it's going to flip over here. And this piece, instead of flipping up, it's going to flip over to here. And even though we flipped across different axes, those two things really look the same. What happens if both A and B are negative? Well, if they're both negative, this piece flipped down to here, and then it flipped over to here. This piece flipped up and then over. So really, these two curves just swapped spots, but it looks the same, right? In terms of graphing, it just looks the same. All right, so now we're going to talk about our key point. We all know where it's at, negative C over B comma D, but what is the key point here? The key point is really this one right here. I call this the COA point. Stands for center of asymptotes. Okay, asymptotes is how you pronounce that. So the place where those two asymptotes cross, that's our key point. And it's going to be at negative C over B comma D. We know that point has to come into play somehow. That's it. And the only other thing that we have to figure out here is what's normal. Okay? What's normal for this graph? And this is a little weird. So you gotta kind of hang with me here, but once you see it, you'll go, oh, this is easy. This is a piece of cake. All right? So let me draw a slightly bigger picture. This isn't even really what's normal. It's this is what we do to get the graph in the right spot. Okay? All right, so let's say I've got two asymptotes that cross. And we know that this point right here is the COA. It's not part of the graph, right? There's not really a point there when we graph this. It's just, I'm just marking it so we know what we're talking about, okay? And I've got this curve that looks like this, and another one over here, okay? And there's going to be a spot where we are exactly 1 unit off this asymptote. The question is, where is that spot? And what you do is you start at the center here, and you go in whatever A divided by B is. So when we look at our equation here, if this is a 2 and this is, well, let's say this is a 6 and this is a 2. If I do 6 divided by 2, that's 3. Then what I'm going to do is I'm going to come in 3 units and go up exactly 1. This 1 will never change. Okay? The A over B will change. We've got to figure out what that is. But we come in that far and we go up exactly 1 unit, and there's a point right there. And you do the same thing here. Come in exactly 1. This is A over B. You do the same thing here. A over B. Go in exactly 1. And you do the same thing here. This is A over B. This is exactly 1. Okay? We're always coming exactly 1 unit off the asymptotes. It's just how far do you go from the center before you come in that 1 unit. And there it is, A over B. Okay, that's it. All we have to do is find the center, draw the two asymptotes. We have to decide if the graph has been flipped or not. So we know where to draw this. These aren't really quadrants, but I can kind of treat it like a quadrant. I can call this the first section, second, third, and fourth. And so our graph will always be in the first and third sections or the second and fourth. It's just, has it been flipped? It's the only question we've got to ask ourselves. All right, let's do an example. We'll do one of these together so we can see how it works, and I'll give you guys a couple to try. So when I look at this, the moment I see that fraction, I know this is a rational function, and I've got these two curves with the asymptotes. So where is the center of the asymptotes? That's at negative c over b, so that'd be a negative 1, comma 3. So if I grab a graph, center of the asymptotes is at negative 1, comma 3. That point is right there. So now what I'm going to do is I'm going to draw a dotted line like this and like this. That's where the two asymptotes are located. And so neither A or B is negative. They're both positive, so we're not flipping the graph. I know I'm going to have one curve up here and one right here. And so A over B is going to be 2 over 1. So that means that from the center, I start here, I go in exactly 2 units, and then come 1 unit up off the asymptote. I'll go up 2 units, come in 1, whoops. I'll go up 2 units and come in 1. And so my curve has to go through those 2 points. We're not going to find a whole bunch of points. We're just going to try and get 2, and then draw a quick sketch of what that looks like. And I'll do the same thing this way. 2 units, come in exactly 1. 2 units, go in 1. Got to hit those 2 points. All right. Now, I don't know. This is really close. But what are some of the things that Judson is picky about on these graphs? Well, one is you shouldn't touch the asymptote. I got pretty close there. I think I just lost half a point. All right. But here's what I tell people. If that happens, just go back and erase a little bit of it. Just erase a little bit. Okay, put some dots back in for the asymptote, and I'll put my arrow there, and all is good. I'm happy now, okay? So that's one thing to be careful of. Here's another thing that happens. Sometimes when people are, I'll just draw this in a different color over here. They're coming along like this, and they go, oh, getting too close, and they turn away. Vertical line test. You can't hit 2 points at once. The moment you turn away, you failed the vertical line test. Okay? So again, if you look at your graph and you go, oh, I shouldn't have done that, go back with an eraser and just erase until it doesn't look like it's turning away, and then put your arrow right there. Okay? Now, the green part isn't even part of the graph, so we're not worried about it. Definitely you do not want to cross the asymptote. If you cross the asymptote, yeah, something's wrong there. We're going to miss points for that. Okay? But really that's it. You know, just make sure that we don't get close and then turn away, because that's not what's happening. We're supposed to get closer and closer and closer without touching. All right? So that one's done. That wasn't too bad. Let me give you guys another one to try. All right, you guys go ahead and try this one. All right, so my first thought here is it's not really written right. Okay, I don't like that. And again, if you don't like the way it's written, fix it. Write it the way you'd like to see it. So we're just going to say that's 2 over a negative 0.5. You know, if you want to call it 1/2, that's okay. X plus 1, right? If this number's positive here, it's got to be positive there. We can't change the signs. And then minus 5. All right, so center of the asymptotes is going to be at -1 divided by a -0.5. I always think of that as, how many 50-cent pieces are there in a dollar? There's 2. Right? So a -1 divided by a -0.5 is a +2. Do it on a calculator if you're not sure, but really I think we should be able to do that in our head. Comma -5. I am flipping the graph across the y-axis. So when I graph this, this is my 2 asymptotes. The graph, instead of being here, it's getting flipped over to this part, and this one will be right here. Okay, that's not my graph, I'm just telling myself here's what it looks like. And then my A over B value, so again, I'm ignoring the negative signs at this point. Right? I already know what it does. It flips it across the y-axis. I just want to know what 2 divided by 0.5 is. How many 50-cent pieces in $2? Should be 4, right? So A divided by B equals 4. Now I'm ready to graph this thing. So asymptotes are centered at 2, -5, which is right there. So let me get my dotted lines in. Let's see, I think I've got, yeah, let's do this. This is a better way to do the asymptotes. And so I know that it's in the 2nd and 4th section, so here and here. I need to go 4 units out from the center and then come in 1 to find my key points. So I'll go 1, 2, 3, 4, come in 1, there it is right there. If I go down 1, 2, 3, 4, and come in 1, so I'm just kind of estimating for that part. Here if I go up 1, 2, 3, 4, come in 1, and here I'll go 1, 2, 3, 4, come in 1. Right? The distance off the asymptotes is always 1 unit. Okay? That'll never change. So now I just draw my curves. So curve would go like this and like this. And I think that's probably a pretty good drawing there. So things that I've seen where people miss points is they get a little careless with this, and let me just draw this again. They just kind of go like this. And what they do is they go flying right past this asymptote. Even though it doesn't extend all the way down, if it did, is it going to hit that curve? And so we just want to be careful. Don't let it happen. So I'm just going to start really close to this point and go up and turn and then go like that. Okay. Just so you guys know this, it's the curve I'm looking at. If your arrow looks like that, you're not losing points. It's not the arrow that counts, it's the curve. Right? This would not miss any points at all. Okay? All right. Ooh, I am starting to curve away just a little bit. Want to be careful there. Since I caught it first, I'll take care of that. There we go. Now I'm okay. All right, let's try one more. All right, so let's see if we can graph this one. All right, so we'll gather our information here. My COA point is at 3 divided by a -2. So -3/2, comma -1. I know that when I draw this graph, I'm flipping across the y-axis again, but not the x-axis. So once again, it's going to look like this. And my A divided by B value is 6 divided by 2 is 3. Okay, again, don't care about the negative sign. I don't have to worry about 6 divided by -2. I just want to know what 6 divided by 2 is. All right, so, even though that's kind of like, yeah, do we have to do that? I mean, it's not that bad. That's a -1.5. So negative 1.5 comma negative 1, it means we're centered right there. And so now I got to put the asymptotes in. So there's one right there. There's the other. I'm just going to put it, you know, kind of right in the middle of those two columns of dots. Let me fix this though. There it is. All right, so now I know my curve is going to be here and here. I got to go 3 units from the center. So when I go up 3, 1, 2, 3, that's not bad. Come in exactly 1. Puts me right in the middle there. When I go this way 3, I'm going to count on the halfway marks. So 1, 2, 3, go up exactly 1. I'll do the same thing the other way. 1, 2, 3, come down 1 unit, and then go down 1, 2, 3, come in 1. Now I'm ready to draw the 2 curves. There it is. We've graphed that function. All right, that's it. That's what we have for today. This is our last basic function that we have to graph. Doesn't mean we're done graphing. We always have the question, you know, what if the equations get really ugly? Got to figure some of that stuff out. But in terms of our basic ones that we should just be able to look at and kind of produce a graph fairly easily, that's the last one. All right. And again, it's really important, you guys. We don't want to just do this and forget it. You know, we want to, this is stuff we want to remember. Like even in calculus next year, I'll go, oh yeah, rational function. You guys remember what that looks like, right? And hopefully we're all going, yeah, it's the one that's got the 2 curves. Yeah, perfect. Okay. All right, let me get you a homework assignment. All right, so this is our assignment for tonight. You know, again, I'm mixing in things that we've already done. Still looking at parabolas where we have to complete the square. Absolute value functions, that's the V graph. Got some cube roots in here. There's a cubic function. Got some square roots. Got a little bit of everything here. Okay? So if you guys can go through this and feel like, yeah, I think I got this, then we've done what we need to do. We got this down. All right? All right, that's it. We'll see you guys later. Take care. Stay safe.